Alrighty, four factors that affect the rate and then go along with the collision theory. So the four factors that we're talking about would be state and concentration and temperature and catalyst. And the three parts of the collision theory are collide, have enough energy, and orientation. Okay. So the catalyst and the orientation, those guys go together. And the temperature and the energy, those guys go together. And the state and the concentration, both about colliding. What are the requirements for something to be classified as a catalyst? You need a couple of things. What are those two things? Yep, facilitate speeding up reaction. And what else? Doesn't get consumed. Perfect. All right, so I got 62 degrees Fahrenheit. I got joules per mole K. I got kilojoules per mole K. All right, so we're going to need the correct units here, and the 62 degrees Fahrenheit's got to get changed, and also this joule and kilojoule thing. So I'm going to switch this to negative 2200 joules per mole. And then I need to do the Fahrenheit. So let's see, that's 62 minus 32 times 5/9. What does that equal? Calculate. 62 minus 32 equals, and then times 5 divided by 9 equals. That sounds good. 16.7 degrees Celsius. And then I'm going to go add 273 to that. And I get 290 K. Okay. And then our equation is delta G is equal to delta H minus T delta S. So my delta H in this case is negative 2200 joules per mole. And then I've got 290 K, and I've got 9 joules per mole. Okay, so the K's cancel out. Let's see what we get here. Negative 2200 minus 290 times 9. All right, so I got negative 4810 joules per mole. Is that right? It doesn't feel right. I think this calculator is a bad calculator. Definitely a bad calculator. All right, so negative 22. Negative 2200 minus 2610. Oh, maybe it's not a bad calculator. Oh, I guess that's right. 4810. Is this going to be a spontaneous or non-spontaneous reaction? Could you have answered this question before we did the math? It had to be a negative number, right? I started here with a negative, and I'm subtracting off a positive value. And I know the temperature can't be negative because I'm using Kelvin. So negative minus a positive is just going to give me a bigger negative. So yep, it's spontaneous. All right, so we want to figure out the order for each of these reactants in this trial. Which trials would you like to use? Okay. So for 1 and 3, I've got no change for A, and for B, I've got a doubling. Okay, so it doubles with respect to B, and then what happens to the rate? The rate goes up by 4, right? So what order must it be with respect to B? 2. So my rate goes up by 4, but my concentration only goes up by 2, so the number that goes right here is a 2. So that's why it's second order. And what about for A? What do you want to do? 1 and 2, I've got it times 2 for A's concentration, and for B it doesn't change at all, and for the rate it doubles. So 2 equals 2 when the exponent for it is a 1, so it's first order. So it's first order with respect to A, and it's second order with respect to B. Okay.